The number line. The set of numbers that corresponds to all points on number lines is called the set of real numbers. The real numbers on the number line are ordered in increasing magnitude from the left to the right. For example, for negative 3.5, 2 over 3 and pi can be shown on a real number line as negative 3.5 between negative 4 and negative 3, for 2 over 3 between 0 and 1, and pi between 3 and 4. Symbol. Okay, for this symbol, description is A equals to B. For example, 3 equals to 3. And here, the description is A less than B. For example, negative 4 less than 4. And for the symbol, the description A greater than B. For example, 5 greater than 0. Note, the symbol less than or greater than are called inequality sign. All sets of real numbers between A and B, where A less than B, can be written in the form of intervals as shown in the following table. Type of interval. Close. Interval notation from A to B, including A and B, solution set X where X greater than or equals to A and less than or equals to B. We present on the number line. We draw from A to B, at A, then circle, and B also, then circle. For open interval, interval notation from A to B, not including A and B, solution set X where X greater than A and less than B, we present on the number line. From A to B, we draw at A, empty circle, and B also empty circle. Half open interval. Interval notation from A to B, including B, solution set X where X greater than A and less than or equals to B, we present on the number line. We draw from A to B, at A, empty circle, and at B, dense circle. For half open interval, for interval notation, from A to B, including A, solution set X where X greater than or equals to A and less than B, we present on the number line. We draw from A to B, at A, then circle, but B, empty circle. Infinite interval. For interval notation, okay, from negative infinity to B, not including B, solution set X where X less than B, we present on the number line. We draw B from to the left, and at B, empty circle. Next, from negative infinity to B, including B, so solution set X where X less than or equals to B. So we draw on the number line. We draw B to the left, and at B, then circle. Next, from A to infinity, not including A, so solution sets x where x greater than A. We present on the number line. We draw from A to the right and at A, empty circle. Okay, next, from A to infinity, including A, the solution set x where x greater than or equals to A. So we draw on the number line. We draw from A to the right and at A, then circle. And the last one, infinity to infinity. Solution set is x where x element of R. R is real number. So we represent on the number line like this. Note, the symbol infinity is not a numerical. When we write A to infinity, including A, we are simply referring to the interval starting at A and continuing indefinitely to the right. Intersection and union for two intervals. Since intervals are sets of real numbers, we can combine two or more intervals by using the set of operation of union and intersection. A. The union of A and B, denoted by A union B, is the set of all elements which belong to A or to B. B. The intersection of two sets A and B, denoted by A and B, is the set of elements which belongs to both A and B. Example 4. Solve the following using the number line. A. Half open interval 0, 5 union open interval 4, 7. Okay, first draw the number line. Mark the number line using the n values of intervals according their values. From both intervals, from smaller value to higher values are 0, 4, 5 and 7. Okay, we mark here the smaller value is 0, next number 4, next number 5 and the last one is number 7. Okay, then draw the line represent the first interval on the number line. The first interval is from 0 to 5. Okay, at 0 we draw, then circle because the number 0 is include. At number 5, empty circle because number 5 not include. For next interval from 4 to number 7. At number 4 and 7, empty circle because not include. What is the solution? Okay, we have to go to relation here, and the sign is union. Union, clue for union. If union have the line, there should be the answer. So the answer, okay, from 0 to 7. We have two methods to write the answer. First method, interval notation. So equals to 0 to 7. 0, then circle, so close. And 7, empty circle, so open. Second method, solution set. So equals to set x where x is greater than or equals to 0 and less than 7. For example B, open interval -5 to -1, intersect open interval to 4. Okay, the first step, draw the number line and then mark the number line using the n values of intervals according their values. From both intervals, from smaller value to higher values are -5, -1, 2 and 4. We mark here -5, -1, 2 and 4. We draw the first interval from -5 to 1. At number -5 and -1, we draw empty circle because not include. Okay, the next interval is from 2 to 4. At number 2 and number 4, also empty circle because not include. What is the solution? Okay, we go to the solution. Refer the sign. The sign is intersection. Okay, what is the intersection? Intersection is the set of elements belongs to both interval. Okay, from the line, any intersection? No. So the solution set is null set. For example, for C, infinite interval -infinity to 7 union infinite interval 7 to infinity. So first step, draw the number line, mark the number line using the n values of interval according their values. From both intervals, the smaller value to higher values are -infinity, 7 and +infinity. Okay, so we mark here number 7. Next step, represent the first interval on the number line. So we draw from number 7 to the left. At number 7, we draw empty circle because number 7 not includes. Next interval from 7 to the right. Number 7, empty circle because the number 7 not include. So what's the solution? Okay, we're going to the relation here. The sign is union. Okay, from the diagram, the solution from -infinity to 7 and from 7 to +infinity. So the solution interval notation equals to -infinity to 7 or from 7 to infinity. For solution sets, okay, set of x where x less than 7 or x greater than 7. For example, for D, infinite interval negative infinity to 4 intersects infinite interval for infinity. Okay, first step, draw the number line. Mark the number line using the n values of intervals according their values. From both intervals, from smaller value to higher value are negative infinity, 4 and positive infinity. Okay, then we mark here number 4. After that, represent the first interval on the number line. The first interval is infinite interval negative infinity to 4. So, we draw number 4 to the left. At number 4, we draw dense circle because number 4 is included. Next, the next interval is infinite interval for infinity. So we draw from number 4 to the right. At number 4, we draw dense circle because number 4 is included. Okay, so what's the solution? We join the relation. The sign is intersection. Okay, from the diagram, the intersection between two interval is number 4. So, the solution sets equals to the set of number 4 only. Example 5, given A equals to infinite interval 9 infinity, set B the set of where x greater than or equals to 7 and less than 13, where x element of z is integer. Solve the following using the number line. A intersect B. First, draw the number line. Mark the number line using the n values of interval according their values. From A and set B, the smaller value to higher value are 7, 8, 9, 10, 11, 12 and infinity. Mark the value on the number line. 7, 8, 9, 10, 11, 12. Okay. Represent the first interval on the number line. For A, infinite interval 9 to infinity. So, we draw the line from number 9 to the right. At number 9, empty circle because number 9 not include. Okay, for set B is integer form, so the value must be 4, number 7, 8, 9, 10, 11 and 12. From the diagram, any intersection between A and B, okay, yes. Okay, so the solution set is the value of number 10, 11 and 12. Set of number 10, 11 and 12. Example 5. Given A equals to infinite interval 9 to infinity, set B the set of where x greater than or equals to 7 and less than 13, where x element of set z is integer. Solve the following using the number line. Okay, B, A union B. Okay, first step, draw the number line. Mark the number line using the n values of interval according to their values. Okay, from both A and set B, the smaller value to higher value are 7, 8, 9, 10, 11, 12 and infinity. Mark the value on the number line. Number 7, 8, 9, 10, 11, 12 and infinity. Represent the first interval on the number line. Okay, A infinite interval, so we draw number 9 to the right. Number 9 empty circle because number 9 not include. Okay, for set B is integer form, so the value must be for number 7, number 8, number 9, number 10, 11 and 12. From the diagram, any union between A and B, yes. So solution set equals to number 7, 8. So you can write the set of number 7 and 8, or number 9 to infinity. Okay, number 9 include, so close, infinity is open.